To write geometric proofs and prove that two triangles are congruent, there's a bunch of things that we need to know how to do. Firstly, we need the right notation. If you see a triangle and then 3 letters, that's just describing the name of a triangle, and those letters will stand for the vertices or points on that triangle. This is the angle symbol. Now, there's a few ways that this can be written. It can also be written like this, with the angle sitting above the middle letter. But generally what this means, if it's angle ABC, it means that B is in the middle of that. So you'll write A out here, B here, and C here. Now, obviously CBA would also be the same angle, and it's not wrong, but most times we put the point that's in the centre of the angle in the middle, and then we put the other two in alphabetical order. If you see 2 letters written beside each other, that refers to a line. So the interval AB would just be referred to as AB. And these 3 lines that look a bit like an equal sign, but they have a third one, just means congruent. And that means identical, not just a similar shape, but exactly the same size and exactly the same shape, no matter whether they've been flipped or rotated or moved about. Now there's 4 congruence proofs for triangles. The reason there are these 4 proofs is that if you ask somebody to draw a triangle and you give them certain instructions, let's just say that I asked my entire class to draw a certain triangle, then if I gave them just the length of the 3 sides, there's only one way they could do that. They'd have to make, let's imagine that I told them to make a triangle that had sides of 7, 8 and 9 centimetres. No matter which of these sides they started with, let's say they drew the 9 centimetre base first, but it wouldn't matter which other one they did. The method for drawing the other 2 sides would be to get a compass, open it out to 7 centimetres and start on one corner and draw an arc at all the places that are 7 centimetres from that corner, and then open up the compass to 8 centimetres and draw an arc from the other side to all the places that are 8 centimetres from that corner. You'll then have your top corner and you can join them up. And it doesn't matter which base you started with. If you give all 3 sides of a triangle, there's only one way that triangle can be drawn. All the angles will then be the same. It might be flipped around or rotated, but it will still be congruent to everybody else's who had the same 3 sides. Now, if you're given 2 sides and an included angle, and the important word there is included, you will also only be able to draw one triangle. Everybody's triangle will be the same. Let me give you an example. If I ask you to draw a triangle that has a 4 centimetre side, a 5 centimetre side, and 40 degrees between those 2 sides, then no matter which one of these sides you draw first, let's say you draw the 5 centimetre side, you'll then, next step in drawing it will be to take your protractor, open it up to 40 degrees and draw an angle going up an indeterminate length. But the following step would be to then measure along that 4 centimetres, and there's only one place that can come to. So you've found your top point. Everybody's triangle will be identical. Now, it's important that you understand that the angle has to be included, because if you gave everybody the instructions to draw a triangle that had a 4 centimetre and a 5 centimetre side, but one of these other angles could be 40, it would be possible for people to draw different triangles. So that angle must be the included angle. If you gave people 2 angles of a triangle, now this proof here could also be written this way. Think about why it could be written this way. Well, because if you have 2 angles of a triangle, you basically have 3, don't you? Because every triangle has 180 degrees in all of the 3 angles. So if you know 2, you basically know 3. And that makes the 2 triangles similar, so that one would be just an enlargement or a reduction of the other. So all you really need then after that is one side that is corresponding, that is equal. Now when I say corresponding, I mean in the same position. So if we've got 2 triangles that have the same angles, let's say they have 50, 60 and 70 degree, and maybe they're in different places, like this, and we're trying to decide if they're congruent or not. First step is they've got their angles the same, at least 2, which means they've got 3. But if they have a corresponding side, let's say this is 5 centimetres and this one is 5 centimetres, that's not enough, because the 5 centimetre sides are not in the same place. This one's between the 60 and the 70 degree angle, and this one's between the 50 and the 60 degree angle. So that's not enough to prove that those triangles are congruent. To be congruent, the 5 centimetre side would have to be in the same place on both triangles. So that's what we mean by a corresponding side, a side that's in the same position of the triangle. Now this last one is almost a bit unnecessary. RHS stands for right angle, hypotenuse and side, and people often get a bit confused and assume that this proof is a little bit like one of these ones that has angles and sides in it because it's got an angle and two sides. In fact, people often confuse it for this one. But it's actually not like that one at all. The one that it's most like is this. Think about it. If you've got a right angle in your triangle, then what you've got is everything that goes along with Pythagoras' theorem. So if you also have the hypotenuse, let's say you know what that is, and you have another side, any other side, isn't it true that you could work this side out using Pythagoras' theorem? And if that's the case, what you basically have by having a right angle and two of the sides, any two, is you have that ability to know all three sides. And that's why two triangles that have this going for them can be proved as congruent without actually needing to find the third side. You can just say it's got a right angle and these other two, and that will be enough.